Okay, so I'm going to go through some of this really quickly until we get onto the object-oriented part of the question. When we do get onto the object-oriented programming part of the question, I want you to pause the video, give it a go yourself first, and then we'll go through a solution. So this is the scenario. A program is needed to plan the layout of a garden. The program will allow the user to create an image of the garden just like this. This will be created. The program will be needing to use abstraction to produce the program interface to represent the garden. Give two different examples of how abstraction could or has been used, shall I say. Well, abstraction is all about simplifying a process. So first of all, you've got no images which are shown. These are the shapes. And also we've got the very fact that these are labeled, which makes it easier for somebody else to take on board and recreate. So you've got shapes with no images shown and and items are labeled. Explain the need for abstraction. Well, I already said it's all about reducing the complexity of the design. This is very simple to follow. It's reducing the complexity for a programmer. If we were to have it generating 3D images or high quality images instead of these basic shapes, it will take up a lot of memory. It will also take up a lot of our processing power as well. So if we were to create an app where the shapes were 3D images, so using 3D rendering, or if it was just high quality JPEGs, and this was an apple tree instead, this was a flower bed instead of just a shape, it would take up our RAM, it would take up our CPU, and it's not really needed to actually develop this garden. I can follow this and I can give this to a garden and I'm sure they'll be able to make it. Okay, so the user needs to input data into this program to set the garden. What pieces of data would they need? Well, we would need the names of the items, that would be input. We would need the dimensions of the shapes. We would need the type of shape. We would also need the location, like the X and Y axis. So apple tree would be in the top left hand corner, patch would be on the right hand side, the far right. Also we'll need data which would be like the number of items, like we've got 2 pear tree, 1 path, 1 flower bed, 1 apple tree, 1 patio, 1 vegetable bed. Now we're on to the object-oriented programming. I don't want you to do this in pseudocode, I want you to do it in program code. Pause the video, give this a go. Okay, so I'm going to make a class, I'm going to call it garden item. We're going to do our constructor, def init, underscore init. And we're taking the parameters of, I'm going to call it user item name, user length, and user width. Self dot item name equals u item name. I can't spell. Self dot length equals u length, and self dot width equals u width, and I also forgot to put self in my constructor. And there we go, done. This question was not asking us to instantiate an object at all, just to set up a constructor with giving us some examples of the data here. Alright. Sorry, I'm losing my voice. So, again, pause the video, give this a go. So what we want to do is we are inheriting. So the trees in the garden are defined by the class tree, so inheritance. So let's do that now. Class tree and garden. So my keyboard is in a really bad position today. So garden item. There you go. Alright, so we still our constructor. And we're going to have self. We're then going to have, I forgot all the actual attributes. Read self dot. So item name, length, width. So we've got u item name, u length, u width. What else? The new attributes, which would be height, sun, shade. Height, sun, shade. And then we've got super. Underscore init, underscore, and it's going to be u item name, u length, u width. Alright, that's easy enough so far. And what we want to do now is we want to, let me just zoom out slightly. There we go. So the new data, so we want height to equal, really I want this to be user defined height, user defined sun, user defined shade. So u height, so we want self dot sun, u sun, self dot shade, u shade. Okay, done. Only one value for these measurements is passed to the constructor. The length and the width of the tree are the same. Okay, so what we could do is we could do we need to make the width and the length the same for the tree. So I'm going to do super dot length equals u width. There you go. So I'm overwriting the width value here, sorry, here, and putting in the tree one. So the length and the width will be the same. It says declare all the attributes as private, so we can use encapsulation for doing that. So let's just do the underscores. Okay. The common oak is a type of tree. It has a maximum height, length, and width of 40 meters. Write a statement in program code to create an instance of the common oak. So I'm just going to call it tree equals, and what we're going to do now is we're going to create a tree. And we're going to pass into it the common oak. We're going to pass into it 40, 40, true, true, because of the data types which were given to us. So it can grow in sun and shade. I actually don't need length. Actually, I do need length. So length. So 40 for length, 40 for width, and we need 40 for height. Which actually means I don't need this because we're setting it down here. Okay, so common oak, 40, 40, 40, true, true. Why true, true? Because it tells us here of the data types. It's Boolean. Moving down. Garden item and tree use a get and set method to access and alter their private attributes. Write the get method for get item name and set name for a garden item. Okay, so garden item, get item name. Let's do it. I cannot type. Return. And set, which was, I believe, to change the name. Okay, so def set item name self. Return. No, not return. Naughty, naughty, naughty. Let's put in here new name. Self dot underscore underscore item name equals new name. Okie dokie. I'm hoping you paused the video and gave it a go on the previous question because I forgot to say that. So on this one, pause the video, give it a go. Okay, so it wants us to create a 1D array called tree array, and this is going to be global, so it's not going to be inside our classes. It's going to be in the main code. So I'm going to make an array and I'm going to call it tree list. Okay, and I'm going to make it equal, yeah, boom. Have we ever built an array based upon an object? Yes, we have. We've done that before. So we can have like 1,000 objects inside our array. So actually what we can do is this. We can say of class tree, we want common oak, we want 40, 40, 40, true, true, for I in range 1,000. However, I'm going to do it for 10 because 1,000 is a pain in the neck. If we want to double check to see if it works, for x in tree list, print x dot get item name. So we should have 10 different common oaks being displayed. There we go. So we built the array, but now what we want to do is create a procedure which will be called find tree. Now, again, this procedure doesn't seem, they're not mentioning the word method, they're calling it a procedure. which needs to take advantage of the attributes and the other methods we've used. So in my main code, I'm going to do def find tree. And then what we want to do is we want us to find a specific tree, and based on requirements, the requirements needs to be height, width, and the grow conditions, i.e. sun and shade. So let's do that to begin with. So let's do user height. In fact, let's just write height, width, sun, shade. So passing in those parameters. We then want to go through each element in our array to see whether or not what we've just entered is less than or equal to the maximum height, the maximum width, whether this is going to be the growing condition, so we're going to enter in true or false ourselves, and we're going to enter true or false ourselves there. It will go through each object. If it matches all of these conditions, then we found the tree, and we'll output a message saying, like, tree found. Otherwise, no suitable tree. So in our main code, let's do height equals int input, enter desired height of tree. Width equals int input, enter desired width of tree. Let's do sun equals input, enter whether or not the tree, let's do enter yes or no. Whether the tree needs sun, and shade equals input, enter yes or no, whether or not the tree needs shade. Easy so far. Then let's call find tree. I need to convert the sun and shade into Boolean. So let's do sun B and shade B, and let's convert them into Boolean now. So if sun equals yes, sun B equals true, else sun B equals false. If shade equals yes, shade B equals true, else shade B equals false. I need some water. Okay, so now we're going to pass in all of this information into this procedure. This procedure is going to loop through our whole entire list, hoping to find the information which we need. So, I'm going to make a flag equals false. The flag will become true if we find a correct tree. For I in range so we're going to loop through a whole list, but let's just do 10. Now the problem is that height, width, sun, and shade are all private. So we need to do our get methods. So def get height self, and return self dot height. Def get width self, return self dot width. No, not in it. def get, what's the other, height, width, sun. Get shade self, return self dot shade. Print tree list. I get height. So if I run this now, my desired height is 30, 30, yes, yes. Great. So at the moment it's just displaying that all my trees are 40. But let's now turn this into the program where I'm going to take the height I enter and compare it with get height. So if height is less than or equal to frozen, less than or equal to tree list, I'm going to just do print true for now. So if I was to run this, 40, 40, 40, 40, whatever, true is less than or equal to my oak tree. Okay, now let's do the same for width. If the width we've entered is less than or equal to tree list, I get width. Print true. So let's do 40 height, 30 width. Yes, yes. Self.width attribute not found. I think I know what the problem is. I put my method here in tree, but width was set here. So let's do that. So I made a boo-boo on that method. Get width, that's fine. 40, 30, yes, yes. There we go. True, 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 true. Now, let's do the sun. So if sun equals tree list I get sun, everything's good so far. If shade equals tree list I get shade, so if all of these conditions are true, what's it wanting us to do? We want a message, so I'm going to say print a suitable tree is found. I'm then going to make flag equal true. If at the end of a loop flag is still false, print no suitable tree is found. We could add a break to the for loop as well, that would be fine. So if we were to run the code now and I was to enter in 40, 40, yes, yes, each tree is suitable. But let's make it not suitable. Let's enter a height which is 40, fine, 40, fine, no, no, no suitable tree is found. So there we go, that is the code. This is our procedure. I added in these get methods. I entered in these inputs to allow this to work. And this is running the procedure. Okay, that'll be it for this question. Okay, have a read of this. pause the video, turn it into code. I'll make it slightly bigger for you, in case you need it bigger. Alright, ladies and gentlemen, so you should have actually given this a go yourself. First, let's rock and roll. We need a class, we're going to call it truck. And in it, it's going to have a constructor. So we need a make, should be equal to the make. We want model to equal the model. We want the self.year to equal the year. We want the self.capacity to equal the capacity. Great. We then want a pickup truck, which is based on truck. Def underscore init. And we're gonna then have our self make model year capacity bed length and 4-wheel drive. We're gonna have our super trooper make model year and capacity, of course, spelled badly. Self dot bed underscore length equals bed length. Easy enough. Self dot for wheel drive equals 4-wheel drive. Okay. What it wants us to do is, let's do the semi-truck first. So let's make another class semi-truck, which is also a type of truck. Def init self make model year capacity trailer capacity and number of axles. And then we want the super trooper. You don't have to find. Okay, cool. And we want the self dot trailer capacity equal trailer capacity, and we want the self dot number of axles to equal, I can't spell, yes I can, number of axles. Why is this underlined? Capacity capacity. Okay. Now let's do our methods. So if I go back for the pickup truck, it should have these as our attributes. You should also create methods for each class that calculate the total weight of a truck and the trailer can carry. For the pickup truck, this should be the sum of the capacity and bed length attributes. Easy. So I'm going to do a calculation method. Okay, def total weight self. I'm going to do return self.capacity plus self.bed length. Nice and easy. That is a total. For semi-truck, this should be the sum of a capacity and the trailer capacity. Okay. Return self dot trailer capacity. What is going on with my spelling? For the semi, okay, hold on. For the semi-truck, this should be the sum of the capacity and trailer capacity. Interesting. So plus self dot capacity. Easy. So if we're going to test this bad boy out, that'll be my pickup truck. But what have I done wrong? Okay, and then let's do print truck 1 total underscore weight and call it. Okay, interesting. Made a boo-boo. Let's see where the boo-boo is. So we've got pickup truck, make, model, year, capacity, bed length, 4-wheel drive, five positional arguments but 7 given. 1, 2, 3, 4, 5, 6. Where have I made a boo-boo? Okay, I'm an idiot. Didn't make my constructor properly, so there we go. Happy days, it's done the calculation for us. And the same would be for the semi-truck. Okay, let's do a different problem. You know the drill. Pause the video, give this a go, see how you do. Okay, well, first of all, we need to look at what the relationship is between these different classes. We've got animal, we've got dog, we've got cat. Animal is going to be known as a base class. It's going to have a method called make sound. Dog is a subclass of animal, but it also has make sound. Cat is a subclass of animal, but it also has make sound. Interesting, so they all have make sound. So if we're going to code this, we'll have class animal. Now, it tells us that the make sound method should be passed. So, def make sound self, and we're going to just pass. We're then going to have dog, which is a type of animal. Def make sound return bark. Class cat, which is also a type of animal, also has the method make sound return meow. It then tells us that we want to the program to have a main function, so in the main code a function. Let's call it main. And what it's going to do is create a list of animal objects. Adds a few dog and cat objects to the list, so it should be bark, meow, bark, and then iterate through it. So that's easy. Let's just do it as a static array. So let's have dog, followed by cat, followed by dog. Nice, easy. For animal, in animals, so in our list, let's print animal make sound, and then let's run it. Bark, meow, bark. What's happening? Well, it's going to create 3 different objects, dog, cat, dog. It's going to loop through each one. Each one it's going to go to make sound, and it's going to display the return value. Hence bark, meow, bark. This is polymorphism in action. This overwrites this. This overwrites this when it's called. Therefore, it is polymorphism. I could do this. Print yo. And let's make another animal. Class dragon. Animal. And let's add dragon here. So notice that this doesn't have make sound. So notice how, well, that should be actually return yo. My bad. There we go. Dog, it does bark. Cat, it does meow. Dog, it goes, runs this, bark again. Dragon, it has no method called make sound, so it uses the default one, which is yo. So polymorphism is basically when the child class has the same method as the parent class, but it overwrites it. So it's useful, especially when we have situations where some child classes might not have, in this case, a default sound. I mean, a personal sound, so we give it a default sound, or even at times nothing, especially when we pass, nothing happens.